Hi all. So today I was going through this DP bootcamp by Priyansh Agarwal. So yeah, I'll solve the so few homework problems are given there in the description. So let's just solve it. I've gone through the video and I've solved 3 problems which were there in the video itself. So let's get started with the homework. Dice combinations. So your task is to count the number of ways to construct sum n by throwing a dice one or more times. Each throw produces an outcome between 1 and 6. For example, if n is equal to 3, there are 2 ways. So we need to count the number of ways to construct sum n by throwing a dice. Let me just note down the question. Okay. If n is equal to 3, there are 4 ways. Okay, so we need to find the number of ways to make this sum. Okay. Using 1, 2, 3, 4, 5, 6. That's it. I think that's the question. So let's just solve. This is CSES 1633. So I'm using CP, I'm using C++ to solve the questions. Okay. So okay. Now so for us the basically the the array, like we can only have 1, 2, 3, 4, 5, 6, these 6 values, right? So the question set, or maybe the problems, the numbers which we'll encounter in our calculation will pretty much be these, right? Yeah. Okay. And for every n we need to tell them how many ways we can produce this number, okay, using these digits. So n will be an input. So example is given for 3, so let's just take 3 once, and then we need to solve n. Okay, so let's just solve. Okay, so this is basically where I'll write the main logic. Okay, let's check. So n is equal to 3 and I need to find the number of ways to make sum 3. It can be 1 plus 1 plus 1, 1 plus 2, 2 plus 1, or 3. I hope they are taking these 3 ways. Okay. Now let's see. Okay. So now since I already know this is DP because I'm following the DP bootcamp, so my first intuition is that we need to break down the problem into smaller sub problems. So like for any particular number, suppose if I have to make, let's just go with a number. Let's suppose if I have to make f of 3, like the number of ways, f basically defines number of ways, okay, to make sum I. Okay, I'm not sure if the font is good enough, like the color scheme. Okay, this is better. So f of I is the number of ways to make sum I. So number of ways to make sum f3, see, number of ways to make f of 1, to get 1, so the number of ways to have a sum of 1 while throwing a dice will be 1 only, right? Number of ways to get 2, or like number of ways to make sum equal to 2 will be 1 plus 1 or 2. So here the net answer is 1, here the net answer is 2. For 3, if you see, to get 3 we can get 2 and then we need 1. So like I'm trying to find the relation, find the pattern here. Do a lot of brainstorming. What I could think was that if only we take f of 0 as 1, basically number of ways to make sums 0 as 1, then I can get the pattern I was trying to look for. So basically in this case f of x is equal to x minus 1 plus f of x minus 2 f of 0. Let me delete these lines. Okay. This happens. Now see, n will be a user input. Okay. Now we can create a vector where we need to store this. Right. Now let me just mention here that dp of 0 is 1. This is a trick, I'm not sure. Like I found the pattern using this, so I'm writing as dp0 of is 1. Okay. Okay. So dp of 1 will be what? dp of 0, right? So okay. So for anything we will, like, for if I is equal to 1, then dp of 1 will be equal to basically our logic is that dp of I will be equal to dp of I minus 1 plus dp of I minus 2 plus and so up till 6, because that's digit, like the dice can only throw these 6 digits, 1 2 3 4 5 6, right? So we can write it in this way, or there's a better way to do it, I think, which is through a sub loop. So j can equal to j can go from 1 to 6, right, and j plus plus. So here dp of I can be equal to dp of so I will be greater than j, right? So I minus j, and then I should be greater than j, right? Yes. Okay. See out dp of n. Okay. Let's see. dp of n. Why do we have so many errors? What is the issue? dp of 0 is 1. We don't need this. Okay, sorry. With vectors, we do not give it like this, right? Arey yaar. Yeah. Okay, so I messed up something. Let's see. We are going from 1 to n, and here we are taking this. So dp of I will be equal to I minus 1 plus I minus 2. So j will work, right, and I should be greater than j. So let's just check. If n is 3, right, n is 3. Okay, I'm doing a try run. Then dp will be, basically the dp vector will look like right, because we are going for 4 values, so all of it could be 0 and indexed from 0, 1, 2, 3, and then I'm doing dp of 0 is equal to 1, so this should be 1. Now I'm going from 1 to n, so 1, 2, 3. So for I is equal to 1, what I am checking is j is equal to 1 and I is greater than j. 1 is not greater, should it be greater than equal to? Then in that case dp of I is, so like 1 will be equal to 0 plus 1, right? So 1, which is 1. For 2, for I equal to 2, we can count from j equal to 1 to 2. So for dp of 2 will be equal to dp of 1 plus dp of 2, right? Like according to our calculation. Okay, no, sorry, this will be So this one is solved. So basically this was the only issue where I had added I greater than j only and not equal to j condition. Okay, that's it. Let's move to the second question.